I will be your host today. My name is Paul Pahovic, and I will be the host for the webinar. I will introduce myself real quick, and then I will speak a little bit about Matti and Peter, who are the subject matter experts for this one. So over the last 10 years, I've dedicated my career to helping companies leverage technology to solve business challenges and achieve faster growth. So today's session focuses on MES scalability and then transformative role of AI. But before we begin, let me make let me take a moment to highlight the collaboration behind this webinar. Etteplan and AVEVA are leaders in digital transformation and are committed to helping businesses to maximize their profits, reduce downtime, and create more uh, predictable and efficient operations. Etteplan is proud to be a certified MES partner of AVEVA, delivering advanced solutions to address the challenges faced by modern manufacturing and production industry. We are fortunate to have two outstanding experts, and I mean it, Matti uh, Partanen and Peter Weiss. Matti is a seasoned leader in digitalization and IoT and data platforms. We'll introduce the key topics, MES scalability and potential for AI in MES systems at a high level. His insights will set the stage for deeper exploration for these critical subjects. Peter Weiss, representing AVEVA, brings expertise in process operations, business development, and product management. Building on Matti's introduction, Peter will deepen the discussion by sharing AVEVA's approach to MES scalability and how AI enriches MES systems, including the benefits of composable architectures. One thing to consider is that we will have two Q&A segments during this webinar because we trying to keep this interactive. We really, care for the questions that will come up during this webinar, and we want to address as many of them as possible. But if we are not able to address like all of them, then we'll get back to you, and then we can have like one-to-one discussions to answer all your questions. So the agenda for today is we have this high-level introduction of MES scalability and the role of AI in MES systems, and this will be delivered by Matti. And then we'll have a deep dive into MES scalability, AVEVA's approach to AI in MES, and the benefits of composable architecture, and this will be delivered by Peter Weiss. And then after each session, we'll have a Q&A space that will be focused on your questions. I think this is time that we can move on, and then Matti, the floor is yours.
All right, thanks, Paul. Thanks, Paul. So points to be considered when scaling MES. So MES is having actually quite a crucial role in ISA 95, and it has to stay scalable and adaptable to keep its position in the future when it's a rather complex environment in manufacturing. And it's getting all the time more and more complex within Industry 4.0 and also with 5.0 applications. So we as an AVEVA system integrator have experienced rolling out AVEVA in different plants, and here are a couple of points that we have faced to be considered in this one. So the first topic is the development speed. So of course, development speed is quite crucial thing in many cases nowadays, especially when you are developing platforms with a longer perspective, whether it's an enterprise data platform, whether it's an MES. So it's about getting an internal buy-in within the company for investment by showing the results, right? So first topic in that one, time to value. So you need to concentrate the things that bring the actual value. In process industry, it's quite often is an OE reporting, and in discrete industry, it's paperless production or production management issues that are faced in time to value things to be done first. Reusability of the components is that it might be tempting in the name of the development speed to either create almost the same things or with a little bit different twists and for different purposes again and again. And otherwise, it's also tempting to create a super generic and configurable views to fit for every purpose. But it needs to keep in balance with the adaptability. And the adaptability is the next issue. So you can consider MES also as the tool in the manufacturing operations, and in the program management perspective, you should also consider that what other data can be shown in the MES systems, because there starts to be quite many applications in the shop floor nowadays. So how can you extend and adapt the MES? Next topic in the change management is that to get the MES actually in the use and make it scale, you need change management, right? So one may say that, okay, we can just tell to employees to use the system, but with the new generations, it might be more lucrative to go another way and make it somewhat tempting to use MES. So in change management perspective, you can consider the user experience as a very important topic, with the digital experiences coming more and more important, even with the shop floors and new generations. Harmonization of the processes, it's also a possibility when you have this kind of a change momentum, creating a new system. It's possibility to harmonize processes between the lines and plants when you are implementing the MES, because MES implementation nowadays is basically digitalizing the business processes in shop floor. And the collaboration, what we have faced that in change management perspective, collaboration is one important thing. When scaling MES, you have a great opportunity to create a community of power users of MES, to share best practices and development ideas between the plants. So use it as a leverage for that one. And in maintainability perspective, architecture as a first topic, of course, this is combined with harmonization of processes in the past topic, quite well aligned with that one, to create a simplicity, because harmonization creates simplicity in architecture. So especially when you have many plants to be scaled, take their processes account latest after the first plant. Because to leverage the real benefits of scaling MES, you need to find similarities from the business processes mentioned, and also possibilities to harmonize the business processes between the plants. So keep the harmonization and the architecture in combine for the simplicity. Performance, of course, is a one thing. Take care of the performance. That this one relates on the change management. High uptime and the performance of the application is very crucial, and also the processes in maintaining application. So leverage the scaling by having a unified application lifecycle management processes, and also unifying that function of the application lifecycle management for MES systems. But all in all, in the bottom, you are still on the balance board. So pushing development speed on the top like a locomotive in program management makes you trouble in the maintainability, and focusing in generalization and architecture makes the development speed go slower in a sense. But keeping all these things in MES program management in the balance and keep them on the table and in discussion, you are then have a good step forward with when scaling MES. All right, but that's my point of view for scaling MES. Peter, can you show us what AVEVA handles and shows when scaling MES?
Yes, sure. Thank you, Matti. Hello from my side to everyone. Thanks for opening and the introduction of our first chapter. Yeah, let's get started. So, every action in market demand requires suppliers to deliver cloud solutions on one hand, but they are also asked about keeping data on premise, at least at most installations that we know. So AVEVA is focusing on a hybrid MES solution as additional offering to allow customers flexibility for deployments. Furthermore, we have realized the importance not only doing a proper MES implementation, but also on doing an implementation in a most efficient way for multiple reasons. An efficient way matters when it comes for sure to our offering itself, but also when it comes to implementation quality. So therefore, AVEVA and Etteplan is following a standard engineering methodology, which allows reuse of existing developments based on standards. And this is called AVEVA's composable and model-driven MES. So the benefits of AVEVA's composable and model-driven MES, there are a couple. I can name some. So faster time to value for sure, simplified and structured URS analysis based on use case discussions, rapidly composed pilots or proof of concepts for a straightforward gap analysis, documented and demonstrable library elements is one thing, improved incremental rollout capability, project deployment efficiency, and finally lower risk, contingency, and ultimately lower total cost of ownership, which is very important. Here's an overview of our composable MES, which is enabled by our modular engineering approach. So the modular engineering approach provides value on 3 pillars. So the main benefit is to increase delivery efficiency, to provide a faster time to value, which improve our competitiveness and reduces the TCO for our customers. The approach starts with standard modules. Each MES module generates benefits for our customers and their implementation experience. A second big value is the improvement of our customers' engagement. We talk of use cases, we can quickly demonstrate what is available. Time for pilots and proof of concepts is dramatically reduced. Our MES modules are industry proven as they embed the experience from our past projects. So we can start small and incrementally grow, as well as more easily than today to address the gaps during the rollouts. So we and our partners like Etteplan benefit of the improved reusability, the higher quality and available documentation whilst implementing a MES solution at our customer sites. So finally, it is AVEVA and their partners having a positive experience together with our clients when using this composable MES approach. Engineering. Here we'd like to introduce the composable MES structure. So when you concentrate, please, on the image on the right, I would start from the bottom with the frame. The frame of this solution architecture consists of commonly used AVEVA products. This builds the backbone of the composable MES solution architecture. The functional modules that you see are the middle layer and independently defined pools of MES-related functionality and UI components to enable the composition approach on the use case layer. These are standard modules that correspond to a MESA definition. Those modules will be placed in a library of modules. Every engineer can use them independent if this is AVEVA or partner engineers. Everyone is getting access. So above you see a solution-specific use case library with all identified use cases to satisfy the requirements of the overall MES solution. The composition engine is the heart of the composability, as it provides the context how, when, and to whom the use cases will be made accessible. On top of that, we have the user interface layer, which provides an innovative, click-reduced, task-driven user interface, which provides configurable access to status information, tasks, and use cases, which are relevant for shop floor operators to execute production on a pre-selected equipment. So finally, a supervisory cockpit provides a persona-related access to information and use cases which are relevant for supervisors. It allows persona-related configuration of this environment. So as a conclusion to this slide, the composable MES and solution architecture enables AVEVA and partners like Etteplan globally to deliver a standardized modular engineering approach with cross-industry applicable use cases for a faster and quality-assured implementation. So further benefits of composable MES for implementation. We are creating early value by deploying existing use cases. So looking at the middle of this slide, we have illustrated the full scope represented by color-coded increments of meaningful combined deliverables. Existing use cases from the library can immediately be deployed if identified to be one-to-one reusable to generate value immediately. Other part of the scope can be deployed in sub-projects and in increments that require changes of existing use cases or the creation of completely new use cases. So each sub-project will deliver a value-added scope in short phases. When we're looking at the upper part of the slide, we see that deployment can be done at any time, in any sequence, and to any extent. So the yellow package are the existing use cases which can be installed, tested, and brought live immediately. Other increments can be deployed at any time after creation. So instead of deploying an entire MES solution to a pilot site, with an incremental approach, we can even deploy particular increments already to the next production sites of our clients. For sure, based on the condition that those increments have been signed off after the first installation. So this approach will help additional production sites to gain value much earlier instead of waiting for the first site to be rolled out entirely. And that is an additional option that AVEVA is offering, and it is up to our clients on which approach to select: full and entire implementation for the pilot site or an incremental one, so that other sites can already benefit from the development and the rollouts. Here I would like to give multi-site projects. So on the left part of the slide, you find the first site which receives an implementation of the complete MES solution. And only if the entire solution or an increment is implemented and signed off by our client, then the composable MES solution with the templates or increment created for our client will be saved in a central repository, the MES Blueprint library. All other sites will benefit from this central repository and can reuse the template or the increment with the effect of no additional development. However, if there's any deviation in a local process, and we heard this also from Matti, a site-specific process, then a change can be introduced to the template or increment and saved as another version to the repository. This will continue from site to site, and over time, subsequent sites might not have any changes to the standard templates and increments. So this whole program will be accompanied by a global program management office and our best practices team. The Center of Excellence will be built by our client together with AVEVA or with Etteplan. And besides our composable MES approach to better scale MES, this project implementation methodology is an additional support to this subject. So with this, I'm finished with the first chapter of today's webinar, and with that, I'm handing over to Paul for possible Q&A.
Yes. Yeah. So this is the time. I'm excited because I've been listening to what you both said, and it seems a little complex. So if there's any questions from the audience, please put them in the chat so we can address those. I think this is very rare opportunity to have Matti and Peter available for a Q&A. So please let me know by putting that question in the comment in the chat, so we can start talking about this. Like we also gonna have another Q&A, but I'd say that I will do it now to make it more interactive. If nobody's willing to ask a question, I will, because I from like all the data that you provided. Like I said, it seems a little complex, but I'm gonna ask a question that maybe can get all of us aligned. So we were talking about scaling MES systems. So what are the challenges involved in scaling MES systems from a single production line to multiple sites? And then the other part of the question would be, and how does AVEVA overcomes these obstacles to ensure smooth expansion?
Yeah, thanks, Paul. That's actually a good question, and I mean, for sure, the fundamental answer to that is that the composable MES itself, with the standard that helps addressing the challenges. But if you're asking me for challenges, well, there's certainly a couple of challenges regarding to your question. So one I can imagine or see is actually the diversity of processes, and we mentioned that already a bit. So depending on the history of the production facility, the processes are not the same. Even within one company, different departments, locations, same product, but processes are mostly not the same actually. And with our composable and model-driven MES, we're able to derive, adjust, or create completely new use cases to compensate this diversity. So due to the modularity, we can modify and extend use cases individually without impacting the rest of the existing solution. This enables a frictionless extension of the solution. Along with that, actually, also another challenge is then the diversity of the equipment. So a central MES solution template requires a standardized data model regarding the underlying automation layer. So what we recommend is actually to decouple the rollout activities of this unified data structure from the MES deployment projects. This enables the expected high data quality via intensive test with the right focus on this part of site readiness. And one more crucial thing probably to mention, and Matti mentioned that also in his intro slide, is operation change management per site. So there's an important need to prepare the receiving sites early enough on what is coming and how this will change their daily life. So professional operational change management, however, needs to be driven by the client. So that's a bit what comes to my mind when you're asking this question.
Yeah, Peter, I think this is plenty for now. Like the topics that we're discussing, they are like extremely difficult. So what we can do during this 45 minutes webinar is we can maybe get this topic a little more like understandable. But those are huge topics. So I think we can move to so that was perfect. So I think that the second part is something that everybody's waiting for, because everybody's waiting for AI to change everything. So I think the second part should be even more interesting than the first one, because it's groundbreaking.
Okay.
So let's talk about AI.
Yep. All right. Let's start to dive into the topic of AI in manufacturing operations and by having what to consider when building custom AI solutions and which kind of use cases can provide the value. So let's take a look at the stairs on the left side. I don't really mean to scare you, but rather remind you about a couple of things of steps when enabling the AI. So when we have the actual manufacturing processes in the place, and the data is stored usually into several systems and it's distributed in there. So first step is to take the data step and gather the data into one place where are you going to implement the actual AI solutions. And in this step, I remind that it's about the data quality because usually it gets more expensive to fix the data when you go upper in these stairs. So for example, system clocks in the different systems are in different times, or some crucial timestamps like acknowledgements for the phases are missing from the data. So it's very important in the shop floor and shop floor development to try to make those corrections as early as possible. So then the data needs to be modeled and harmonized, and it's understandable format, and further processing and implement selected AI models. Then having the insight from the data and securing that the insights are real, like recommended process parameters, for example, are they actually the best parameters for the process? So don't blindly believe the AI. They have to be verified that it's correcting the answers are correct from the AI. And then, of course, taking the action step. So when the recommended process parameters are taken into use, so usually the wanted value in manufacturing is like an efficiency or better quality and employee empowerment in the value point of view in the right side. So you need to take these stairs and make the actual actions based on the insights and the data, and then you get the value. And on the bottom side, right side of there are three most common traditional use cases of AI in manufacturing, like predicting machine failures and optimizing uptime and quality control, whether it's based on cameras or detecting anomalies in production, or process optimization, for example, what mentioned, like a recommended optimal process parameters finding and so on. But what I have seen is in the need in the field, and what we are as an Etteplan have made some investments also in generative AI, which actually fits also quite well in manufacturing operations. So the process improvement in Gen AI can be automized and standardized by having discussions with process improvement chatbot or assistant, how we do call it. And when you combine processes like Lean and Six Sigma and make it combined with generative AI, and it's about the discussion. So then you can harmonize and standardize also those kind of process improvement processes. Reporting automation is one, so part of the production reporting can be automated on the same way. So having guided and interactive discussion between AI assistant and human, and of course it's still crucial to keep the human as a part of the process. And the production assistant is the relevant information much faster and create guidance to shop floor workers more efficiently. So in the old times you have to make quite many manuals for different things, and then they are tried to be searched in the shop floor. But consider combining MES information of current production situation, workflows, instructions, maintenance information, and worker describes the situation what he is having right now, which of course already can be partly known by the MES information, like worker is having certain trouble with the machine. And then the assistant tells the worker what to do next in this specific situation, and the production assistant can take account of the current production situation. So it makes creation of this guidance much faster to use generative AI for that one. So that is something new in my perspective in manufacturing operations and AI. So this is the high level perspective how I can see the AI in manufacturing operations right now. So Peter, I think AVEVA is having quite interesting products also in this side. Can you tell a little bit more about those ones?
Yeah, I hope we have something interesting for you, but I guess we have. So let's have a look also first a bit more on the high level. So what we have here, these are the typical improvements MES is able to deliver and manufacturers can achieve. So the figures on the right are an average from known installations. However, it's not the MES itself helping to achieve such results. MES just provides the data and information needed to enable the user performing process analysis. And at the end of the day, it is the user of an MES who needs to understand all that information provided, running a proper analysis, and taking the right actions to reintroduce identified process improvements to the manufacturing process. And here's exactly where AI delivers the benefit for MES and manufacturers. So AVEVA provides through our Connect Industrial Intelligence platform, so just that you heard the name of it already, an AI assistant to access any MES event data. You can use our advanced analytics solution from this platform also to drive more concrete results of process statements to be made, and the AI assistant or the generative AI are the tools to help you finding relevant data for analytics. Much faster, a time-consuming and sometimes unreliable search for information, that will be history with these kind of solutions and tools. So with the precise questioning for information needed, you will immediately get the result and information you need for process improvements returned from the assistant. As such, you save a lot of time to look for data, and you will be able to improve the quality of your analysis to take actions. So therefore, the average figures shown in this slide have the chance to even improve further with such application, and to be achieved faster, to also improve ROI of such an investment. So as next, please see a video to get an impression of this platform and assistant. The generative AI, as Matti said, is probably the most interesting. That will be shown at about minute 2:30. So enjoy the video, and we'll be back soon.
A corporate function staff member from the global operations team completes their daily morning routine by reviewing an overview of productivity from multiple plants. They identify a trend of decreased productivity at the New York plant and raises their concerns to the plant manager for the site. The New York plant is informed about the flagged concern related to productivity for the plant and begins investigating. Using the Connect dashboard, the plant manager drills down through the plant overview to analyze performance of assets associated with BruTrain 100. After identifying variation in equipment process temperatures, the plant manager requests a diagnostic analysis by a plant engineer. A plant engineer receives the diagnostic request and begins their analysis. The engineer uses teamwork to check for existing maintenance or issue reports related to the flagged asset being viewed on the dashboard. After investigating the performance of MASH 100, the engineer is satisfied that the equipment is operating within acceptable parameters and widens their investigation to include assets from bottling line 1. Using the information on the dashboard to assess asset uptime, the engineer offers preventive recommendations to operators on how best to reduce or eliminate the threat of downtime at the plant. The plant engineer identifies extended downtime for the bottling line over the last 24 hours and creates an issue report to initiate an investigation by the maintenance team into the source of the machine stoppage. A maintenance engineer receives a notification from the plant engineer, assigning them to investigate the machine stoppage on bottle line 001. They open the report and set the status to pending while they complete their assessment of the asset. A maintenance manager takes over at this stage and uses the maintenance dashboard to review detailed reports for sub-equipment pieces of the BruTrain 100 asset. They review PID documentation for MASH 100 ahead of planned maintenance to the asset at a later date. After reviewing plant maintenance documentation, the maintenance manager also reviews plant data related to sustainability to investigate the impact recent downtime has had on the power consumption and emissions of the plant. They also review quality data for goods produced or in production to assess any impacts to the supply line. In order to complete the final stage of investigation started by the plant manager, and following on from the operations team's morning meeting, staff at the plant use the industrial assistant to identify key plant operational data quickly and effectively. They use the assistant to investigate downtime of assets associated with BruTrain 100, check the historic equipment states for the MASH 100 asset, and assess the utilization performance of MASH 100 over the last 24 hours. This information is then compiled into a report and is returned to the plant manager. That concludes this demonstration on ensuring operational efficiency in.
Yeah, thanks for watching the video and listening to it. So you've just seen the visualization services AI assistant, which is included in the Connect platform. So Connect offers a distinctive advantage in the marketplace because of how we are unifying data, AI, and deep domain expertise across our portfolio of solutions and offering them to our customers in one central location in the cloud. So our proven industrial applications offer trusted intelligence and provide customers with a single source of truth. Actionable insights help our customers close the loop and enable them to make decisions in real time that impact the business. Our unified experience brings together hundreds of applications, data sources, etc. into one centralized view, making it easier for customers to get a clear view of their business in a central location. And through our empowered ecosystem, we are enabling our expansive and boundless network of customers, producers, partners, and vendors to collaborate in a frictionless environment. So how MES is connected and what else to know, you will see on the next slide. So as mentioned, Connect is our industrial intelligence platform. It is an open platform, neutral, provides the foundation from which we are empowering our customers to build their unified industrial ecosystem. Connect has 5 types platform services available, but today I'm just elaborating on the boxes that you can see in yellow. So the data services, as the first box, is also known as AVEVA Data Hub. It is for aggregating, storing, sharing, and contextualizing your industrial data from across your ecosystem. The second is the visualization services. The visualization services are for creating robust dashboards and persona-based experiences from predefined and custom content using data from Connect as well as other data sources. This is the application that you saw in the video. The third one is the modeling and analytics. So with AVEVA Advanced Analytics, that enables you to maximize the value of your operations data by generating real-time predictive and prescriptive insights using AI. So this means that besides MES data being saved in Connect data services, you can have any additional data from any other application and third-party data source from the field, loading data into data services. Therefore, AI can combine information from anywhere in the field with MES and take benefit from this. So Connect is a central data platform in the cloud to collect and use data from any production site of a manufacturer landscape. Now, let's go through the advanced analytics predictive operations process. So once the data is connected and we have vetted with the customer which of the templates we want to start with, we then build our first model using one of the 6 model templates. We build our first model or predictive digital twin. You configure this model with all of the analog values for that production unit, production line, or the plant. The software will learn the cause and effect relationship in the tags and generate an operational digital twin, for example, the predictive model. And this model understands what the normal operating modes are, as well as the parameters that are the most correlated and therefore provide the most contribution to the performance of the model. You tune the model by removing the data points that the software shows you that are not impactful for the output you're looking for. And then you set your first model up for active monitoring. And one key benefit to point out here is that often you learn within such process more about what impacts the performance of operations than you may have previously realized. So the assistant will retrieve the real-time operating data for each of the input tags into the model, and the model will calculate the output, continuously assessing the performance of the digital twin. And when there's a performance issue, then an alert is sent via an inside newsfeed alert. And this alert contains an anomaly score as well as the top 3 contributing factors to B anomaly. So the higher the anomaly score, the rarer the event and the more attention to pay to it. The model results also can provide the recommendations to improve the result, meaning what are the process parameters to adjust to get your process back to target or which ingredients mix to modify to achieve the optimal energy use per unit of production or optimize quality. So once the adjustments are made, then the machine learning algorithm learns from the modifications, effectively the new modes of operation. Yeah, and since this only takes 1 hour to build a model from the template, we can now try the next model and set it for monitoring. So this process continues day in and day out to implement new solutions and solve new problems and have a highly digitized process for improvement. We are not just giving you a technology for a predictive model, we are delivering an end-to-end continuous improvement process that is built inside the assistant and leveraging data in the assistant. So that was a lot of information, but concluding, what we are offering is a modern and highly digitized continuous improvement process. Starts by bringing data into a model, using technology to monitor the equipment with detailed alerting to not only identify when a process is behaving abnormally, but also to identify recommendations as to how to improve the process on a real-time basis. It's just an overview. These are the AI assistant key features that support to help MES and operations benefit from AI. So this is the natural language interface, content search and summarization that is used, citations to show our work, generation of charts inline. So these are the key features. So, but how will this be visible in manufacturing? And therefore, the next slide I wanted to show you, that is an example of a production site of a chemical industry. So here you see a typical production with an example of chemicals. So processes behavior. So at the end, you will improve uptime, quality, performance, operations in general. Please remember what I said at the beginning. It is the user taking the right action from an analysis performed to achieve these optimizations. Now with the use of Connect and AI, additional value will be unlocked. So with the use of the given advanced analytics and AI, now you can achieve predictions on quality, energy, production, batch and uptime, something not possible with just a classic MES solution functionality, as now you can predict it. And with AI or the generative AI, you will achieve those results much faster in your daily business, more precise and effective. So every day's interaction with AI or generative AI saves time for analysis and improvements. The ROI and as such investments in digitalization will return much better confidence. So to confirm all what I have presented, let me show you as a last slide a success story from one of our customers. So the technology and potential for operations as just presented has been proven in a project with our customer Amcor from the packaging solutions industry. You can read on your own quickly the challenge, solution and results on the left side. In this case, it was the capability of AVEVA Advanced Analytics in collaboration with the AI assistant that detected a process anomaly and saved our customer a huge loss in production. And that was just one case. And according to Carlos Paredes, the opportunity for further improvements are exponentially huge. So whether it is process predictions or faster and more accurate analysis you can perform, our Connect Industrial platform with all its services and artificial intelligence solutions will use MES event data and other application data to help you improving operations towards operational excellence. Yeah, with that, I'm at the end of my presentation, the second chapter, and with that, I'm handing over to you, Paul.
Yeah, thank you. It was actually what I expected. So I even got more than I expected from this, because yeah, this is really a breakthrough, I think. So just listening to both the presentations, there's one question that comes to my mind, and that question is, how do we get started? Of course, you are like subject matter expert on the topic, but I want to now summarize and say something that is very universal. Is how to approach projects like that. So the best approach is to begin with assessing like your current process, and identifying the areas where you see opportunities for improvement, and then starting by organizing workshops to evaluate the current state, and define the desired future state, and then focus on the areas that offer the most business value. I know this maybe seem like a pretty obvious statement, but I still feel that at this point, this is important to mention. And then choose a well-defined smaller area to begin with, uh, somewhere you can test the features in controlled environment, and this initial step can take you from proof of concept, which then later can evolve into a pilot project. So this approach follows flexibility and makes adjustments in something if something doesn't go as planned, uh, while also setting a solid foundation for scaling up. So this one sentence that I'm gonna say now is something that we live by, and it's think big, start small, and scale fast. So if today's webinar has promoted any ideas or questions, we'd be glad to discuss them further. For now, I will open the floor for any questions that you may have. But before I do that, I want to make sure that everybody knows how to ask a question, because this is like one-way communication. Like we were talking to you a lot, and now I want to make sure that there will be some questions from the audience. And if you look at the right top corner of your screen, there should be this question mark. And if you have questions that you like to ask, now this is the second part. So we'll be talking about AI. Please put the questions, put your question there. And we have Peter and Matti here to Peter and Matti that will be challenged by the question, I think. So please do that. Waiting. I really, I really like to see a question that comes from the audience in regards of AI. But if there is no question, I will try to challenge Peter and Matti. So you mentioned the platform, Connect, and what is the primary what are the primary users of that platform? It feels like there is a lot of data involved. Is it necessary to hire a data scientist to work with the system? Because it seems great, but do you need the data scientist to run it, or not?
Yeah, well, the straightforward answer to that is no. So basically, everyone can use the system. It's accessing the system using the data via the assistant, and this solution is designed to enable self-service for any user, right? So it contains out-of-the-box analytic content for the AVEVA MES or MOM applications data. And you have access to predefined dashboards. You can see editable dashboards. It is a pretty easy drag and drop of information from the MES system. You can use whatever chart you like to see, and you just drag and drop the variables into that chart. you can arrange various content types. It is a no-code experience, so that's really not rocket science. And with an introduction given to the users and some hands-on experience, for sure, need a bit practice maybe, but everybody can manage the setup of the dashboards and having the user experience. So you don't need a data scientist for that.
Great. Thank you.
I could even do it.
Maybe I could even do it. So yeah, I don't see any questions coming from the audience, and I wish they were, at least some kind of like Black Friday, question. we were ready to do that. We had this opportunity, 30% discount on your next rollout, but nobody asked. So I think we're just gonna sum it up. Thank you, Peter. Thank you, Matti. And yeah, if there's anything that you wanted to ask but you didn't, there is still opportunity. Please reach out to us and let us know. Any subjects that will be interesting to you, or subjects that you want to discuss. Feel free to do that. So thank you so much for showing up. Thank you so much, Peter and Matti, for making this happen. And have a great weekend.
Thank you, team.
Thank you.
It was great.
Thank you. Take care.
Bye-bye.